Now we are going to understand about relative velocity in one dimension. Okay, let's say this is car A and this is car B on same road, straight line road. It's move with the velocity VA. This car move with velocity VB on fixed direction. So VA is velocity of car A, VB is velocity of car B. Assume here these two velocity are uniform velocity. So here uniform velocity, here also uniform velocity. Uniform velocity in the sense it displays equal displacement in equal interval of time. Okay. Now actually my interest is to find relative velocity of A with respect to B. Relative velocity of A with respect to B is what, and the relative velocity of B with respect to A. Generally, we can study about what actually AB vector equal to OB vector minus OA vector, position vector. OB vector minus OA vector as a position vector. Just like that, same way we can write it here. VAB means uh, VA minus VB here. Now this velocity of A with respect to ground, velocity of B with respect to ground when moving on a road in same direction. This is relative velocity. Actually, a systematically graphical understanding we must acquire. So that I'm going to draw the graph first. So this is y axis, this is x axis. Meeting at the origin is origin 0, 0. I'm just making x-axis as a time. It is independent axis, dependent axis. It is displacement y-axis in meter in second. Clear? And just draw a slope. This is uh, this is one slope. Another slope is like this. The two slope having same angle with the x-axis. So I know very well about when these two slope are equal, the two slope is equal to one another. So I can say this is B vector, B car, this is A car. So this is initial position of A, this is initial position of B. So now time going along x-axis, uh, displacement going along y-axis. So any time we can say the slope on this line is same. So on this line is same. Slope means this is a parallel line to the x-axis. So making angle theta with x-axis is same on everywhere on this line. So so that is why I am saying VA equal to VB. So two lines are parallel. Line A parallel to line B. So slope are equal. Slope of A is equal to slope of B. Slope means I'm just drawing this 2 point having this is y length, this is x length. Y length will be del y, x length will be del x. Del y is a displacement, del x is a time. Clear? Now I'm going to define the tan theta will be tan theta. What is tan theta? Opposite by adjacent, del y by del x. Here tan theta means b and del y means del x here, and del x means del t. So that is why it is a constant uniform velocity, because everywhere along this straight line having same slope. So tan theta is constant, so velocity is constant. Uniform motion. It is mentioned here, uniform motion. Clear? And then actually car A is here, car B is started here. So car B is ahead of car A, car B is standing ahead of car A. So car B having velocity 30 kilometer per hour. So car A also 30 kilometer per hour, kilometer km by r. So that distance between these two vehicle is 30 meter. So always keeping 30 meter because having everywhere having same separation. So here this cars moves with a velocity of 30 kilometer per hour. So it's move along this straight line. Anyway, it's keep constant separation. So it even though it is moving with velocity of 30 kilometer per hour, each car having a 30 kilometer per hour, the separation always keep constant. This separation always keep constant. Okay. Now I'm going to uh, do one thing. Actually, I'm making a new page. Okay, I'm going to define velocity of A is equal to x a of t minus x a of 0 divided by, this is final position of A, this is initial position of A. So shortest distance between these 2 points is displacement over this time. Actually, uh, in this position, time is t. For in this position, time is 0. Now, we can understand about x a of t, x a of 0 equal to va into t. The same wise, xb of t minus xb of 0 is equal to vb into t. This is equation 1 and this is equation 2. The car, two car, VA car and VB car moving on same direction. Already we got. So equation 2 minus equation 1. What we got? XB of t minus XA of t equal to XB of 0 minus XA of 0 plus VB minus VA of t. Clearly we can see here over here velocity of B with respect to A is relative velocity of B, relative velocity of B with respect to A. We can understand about VBA. Here now we have VB, velocity of B with respect to ground minus velocity of A with respect to ground is equal to VBA. Here this is relative velocity of B with respect to A. B with respect to A. Relative velocity of B with respect to A. Same as we can say that relative velocity of A with respect to B, we can write VAB equal to VA minus VB. So relative velocity of A with respect to B is equal to relative velocity of A with respect to ground minus relative velocity of B with respect to ground. Clear? So individual velocity with respect to ground. Already I said it. This is how do we understand about relative velocity, and more graphical understanding we must need. Okay, so when graphical understanding we got means we can easily solve the sum. Okay, so now I'm going to make a new page here. So I'm naming here, this is xb, b object, this is a object, initial position of A at this point. Clear? 0 comma 0, initial time is 0 time, this is displacement x. So this is a position of at the t equal to 0, initial position of B vehicle and A vehicle noted down. And this is what actually A vehicle ahead of B vehicle. A vehicle is before, B vehicle is back. Okay, actually there's two vehicles keeping distance like that, this much distance kept at initially. Actually, this having slope like this theta, this having slope like this theta. This is much steeper. V object having much steeper. So VB velocity is more than VA velocity. Even though it started with some distance apart, actually B object is overcross the A object, overcome the A object. At this point of time, it will overcross B object to A object at this time. Okay, so actually when this two vehicle moving in same direction, so this is the point it will meet each other and overtake here. This point, overtake point. Okay, this much time B object take to overcross so of A object. Yeah, when uh, these kinds of things are understood well, so we need to understand another one. Actually, another one is when two objects moving in opposite direction. Two objects moving in object opposite direction. What would happen when this is B object moving like this, A object moving like this? This is A object. This is B object. So actually, A object, B object moving opposite direction. B object. This is A object in a straight line moving opposite direction. So this is initial position of B. This is initial position of A because 0 comma 0 here, and this is the point where this two vehicle crossing each other. Okay, overtake, crossing each other. Actually, this two object moving in opposite direction. So VB plus VA, velocity of B with respect to A. This is addition. Right? Note that when two train going opposite direction, you are here watching this train. Actually, your train going 100 km per hour. The opposite train also going 100 km per hour. When crossing each other, your perception having just like that your train is going with a 200 km per hour. Your perception will be the relative velocity at this time. Yeah.